Good morning, everyone. I'm Raffaele Summese from University of Twente, and today I'm going to talk to you about these amassing country code top-level domains from public data. This is a work that I did in collaboration with my colleagues Roland and Matthijs from University of Twente, and I'm glad that this work won the Best of CCR award from this year, and I have this opportunity to present today's at SIGCOMM'. So let me give first a bit of motivation on why we did this work. We did this work because the web has vast and intricate network of interconnection has been subject to a lot of study, both from technical, economical, and policy aspect. But the common things of all these studies that all of these studies starts with a list of domain names that serves as fundamental building block. And these domain names can include top-ranked domains or domain, for example, extracted from zone file of top-level domains. The reason why we are interested in domain names is our project OpenIntel, that is a research-oriented large-scale measurement platform that is scanning around 65% of all registered domain names every day. We are currently scanning 306 million domains daily and 10.3 trillion data points we collected. We have 10.3 trillion data points collected since 2015. And we had more than 60 papers of different academic collaboration made possible through our data. And the goal for us is to be the long-term memory of the DNS ecosystem. So to be able to answer that question, for example, how Google.com infrastructure looked like 10 years ago. We rely on domain names for feeding our measurement, and in particular, we have several sources of domain names. The first source is, of course, the public top list, so the Alexa, SIGCOMM', Tranco, Cloudflare Radar top 1 million domain names. So these are a list of domain names or really popular domain names. They are great because they are public, but the problem is that they are biased because they just give you the picture of the popular names that sometimes is different from the picture of domain names, for example, that are not visited that often. And then we have zones, for example, from Switzerland, Estonia, Sweden, France, that share their zone file publicly. So they share the list of domain names that they serve in a public way. They are great because they are fully representative of the country, they are public. Then we have zones that we collect through the SIGCOMM'24 platform, and these in particular are one of the GTLDs. GTLDs are the, for example, .com, .xyz, that are not are top-level domains that are not linked to a country but are generic top-level domain. And when ICANN basically expanded this list of generic top-level domain, including, for example, new top-level domains such as XYZ, they mandated these TLDs to share their zone to this platform. And through this platform, basically, researcher can request access to the zone and enter in an NDA agreement with the zone owner to get access to the zone. It's a really easy process, but there is a problem. That is, the NDA agreement that you enter with the zone owner basically forbid you to reshare the data. So in case of OpenIntel, we cannot reshare the measurement data. And then we have a series of CCTLDs that we call the NDA CCTLDs, because CCTLDs that we had to go through a long, bureaucratic and complex process to obtain access to the zone, sometimes years, because sometimes you need personal contact in TLDs to convince people to get you access to the zone. Through this process, we got access to 13 CCTLDs, but these CCTLDs are under NDA, so that means we cannot really share the data that we collect from the measurement seeded through their zone. To recap, what's the problem? The problem is that we have a lot of barriers in data sharing that hurts the research community because we cannot really share the data in an open way as we wish. And the other problem is that while a lot of researchers nowadays can access to GTLDs through the SIGCOMM' platform, the web extends beyond GTLDs, and country code top-level domain arguably represent a significant portion of the local internet landscape. For example, if you consider Germany.de, all the domain hosted on .de tells you a lot of information about the evolution of the web in Germany. And so this lack of transparency basically leads to an underrepresentation of CCTLDs in kind of research that we do, limiting the understanding of the global and regional web ecosystem. From the other side, CCTLDs, of course, have concern because, contrary to GTLDs that are under the governance of ICANN, CCTLDs are governed as a small matter of local policy, so they're needing to obey to the local government, and often these policies severely limit their data sharing possibility to privacy and liability concern. And in particular in Europe, GDPR complicated the matter because some countries things that, for example, domain names are or considered domain names as personal identifiable information. This causes trouble because they cannot share this personal identifiable information. So we asked ourselves, okay, we cannot really get access to this zone. That was our last hope. And the truth is that we believe that that was not our last hope. So we started to investigate if there is another hope to obtain a large list of domain names through public sources, through sources that everyone can access to. And we explored two paths. One is certificate transparency log, and the other one is common crawl data. And we wonder how representative these two sources are of the CCTLD landscape. And to do so, we collected basically a sizable and sustainable amount of domains from certificate transparency log and common crawl. CT logs, for one of you doesn't know, are basically public log that track the issuance of TLS certificate, and it's required by popular browsers, and now TLS certificate are basically present in these CT logs. And Common Crawl instead is a vast repository of web crawl data. It's updated every 2 months, more or less. We basically consolidate this dataset. We amass domain names from this dataset. We extract, amass, and consolidate domains from this dataset, and we compare these domains that we collected from these two datasets with the ground truth of CCTLDs. And as I mentioned before, accessing CCTLDs, it's very difficult. In OpenIntel, we have 19 CCTLDs that we managed to get access. They are out there. There are around 300 CCTLDs. 12 CCTLDs were collected through NDA agreement, and 7 instead were public. And we did this comparison over a longitudinal time frame. We compared the data from 2018 to 2023, so 5 years of data. What we learned is something really interesting. We learned that basically half of the zone of CCTLDs can be learned to public data sources. So half of the zone is sort of already public. And we saw that basically this coverage varies in 19 CCTLDs that we examined from 43% to 80%. And this coverage is also increasing over time because we went from an average of 37% in 2018 to an average of 59% in 2023. And this somehow already sort of negates the privacy concern of the CCTLDs. Because if we can learn these domains through public sources, there is less privacy involved, I would argue. One interesting zone here that we really were surprised is the .ru zone, that arguably is like a zone that's really difficult to get access through. And what we saw is that basically the coverage using public sources is almost like 72%. That's a really high number. The next step that we did in our research is try to break down basically which is the contribution in coverage from CT logs and which is the contribution in coverage from common crawl. As I said before, on average, they let you learn around 59% of the zone of a CCTLD. And of these 59%, 24% was both appearing in CT log, where domain both appearing in CT logs and common crawl, 28 only in CT logs, and 70% only in common crawl. This tells you basically that with CT logs you can learn already a lot of domain names, and common crawl add a small value in capturing additional domain names. Another thing is that we noticed that this additional coverage provided by common crawl is decreasing over time, and this is possibly due to the fact that basically more and more websites are adopting TLS, so these TLS certificates are pushed to CT logs as a requirement from the browser. And that means basically that we see more and more overlapping between CT logs and common crawl. Another interesting question that we posed was the fact that how late we are basically in detecting newly registered domain name by using this approach. And we saw that basically nearly 60% of newly registered domain names appearing in CT logs were appearing on the same day where they were added to the zone, and 80% of them were appearing within 5 days. And the reason why we did just with city logs is because city logs is updated continuously. Instead, common crawl data are updated every 2 months, so it's a bit more difficult to do this kind of comparison. But this result basically tells you that city logs can really provide timely data about newly registered domain names. Then we asked ourselves if we can really generalize this result because 19 CCTLDs over 300 CCTLDs that are out there seems like a small number. So with this experiment, we assessed the coverage over the GTLDs. We checked in 2023 for the 1,153 GTLDs that we collect, which was the coverage by using public data. And we saw that basically while this coverage varies, it generally falls within the range of 38 to 80%. It's more or less the same percentage that we saw for the CCTLDs. And in general, larger GTLDs tend to have higher coverage rate. But our result is basically confirmed that public sources can provide substantial coverage across different TLDs. To conclude this talk, I would recap that basically city logs and common crawl really can provide visibility on more than half of the CCTLD domains and zone out there on average. And while our effort in data sharing in the past has been curbed to contractual agreement, with this finding, we will now share more because we can start to share domain names that appears in city logs and common crawl because they are publicly learnable. And since January 2024, actually, we started to measure all the CCTLD domains that we can collect through city logs, and we will make more and more measurement data available soon. We also hope that these results also can spark a discussion with CCTLD's operator because we understand their concern in terms of privacy and in terms of reliability. But we argue that more transparency and more data sharing effort inside the DNS ecosystem can really help the research community to build a more stable, a more secure, and a more resilient DNS and web ecosystem. Thanks a lot for your attention. And if you have any question, please reach me via email. And thanks a lot again.